find the probability that a shopper will be in the store between 24 and 54 minutes. So if I choose a random person, the probability that that random person is going to stay between 24 and 54 minutes is about 75%. That's a pretty strong probability, right? And that's a pretty big range if you ask me. Most people, when they go shopping, don't they kind of stay for at least like a half an hour to do their shopping? I know me, it takes me like 5 times around before I find everything that I need. So I end up spending a lot more time than I wanted to. There's always those few things that you say, where the heck is this? Okay, so now, this is also used as a forecasting tool. On the average, this is what I expect to find. So if 200 people walk into my store at the same time, how many of those people will I expect to last between 24 and 54 minutes? So I take the probability and I multiply it by 200. I don't know. It's 200 people. So I come up with, out of those 200 people, this amount will stay in the store between 24 and 54 minutes. So I have to round this. So rules of rounding say this should probably round up to 147. But I haven't really hit my 147th person yet. So if you round to 146, it probably makes more sense. But if you round to 147, in this case, I'm fine with that. Remember, people are discrete variables, whole numbers. We count them as whole numbers. So we find your probabilities, so we find your z-scores, we found your areas in between. That's the probability that a random shopper will stay in my store between 24 and 54 minutes. So if I use this to predict the next 100 people, the next 200 people, this is important. I need to know how big my store should be. I need to know how many products I should have on my shelves, how people are going to stay, how many people I need to work my registers, right? If you have a lot of people in your store staying this amount of time, you don't want them to get to the register and have 2 people on the register, right? If I have just a few people in my store, then I might not need this many people. You kind of feeling this? Does it make more sense when you see it with a scenario rather than just find the z-score, find the area, and say 0.7333? Think of it like that's why I like to think of the areas in terms of percents, because probabilities look closer to percents. Okay, let's take this part. The probability that a random shopper will last more than 39 minutes. So do I say greater than or less than? Greater than. So that it's more than 39 minutes. So I look for 39. It's somewhere right here. Do I want to shade to the right or to the left? To the right. More than. The arrow points to the right. Will this estimate be more than 50% or less than 50%? More than. So I do my z-score. And again, it's in the negatives. So I'm the smaller, which is my x, minus my mean, over my standard deviation. So when I do this, I get negative 0.5. And did I expect it to be between a 0 and a negative 1? Yep, I expected it to be there. So now, I look up my area for this, and it says 0.3085. We said more than 50%. So we're right, more than 50%. So what do I have to do with this guy? Subtract it from 1. Because this is my area to the left. And that's right, this little area to the left is smaller than 50%. I want the area to the right. I want to subtract it from 1. So 0.6915. And what does that mean to me? The probability that a random shopper will stay in my store more than 39 minutes is about 69%. Good percentage, right? They're hanging out in my store. If I trended this for the next 200 people, I would just take this and multiply this by 200. If I multiply it by 200, I would get about 138 shoppers. Out of the 200 that would stay in my store for more than 39 minutes. That's a good long time to be in the shopping store, right? Are we kind of seeing these? Okay, so you are going to do the same thing for try it too. It's the same information, but try it too says you're in between the stores. You're between 33 and 60 minutes. What is the probability that a random shopper will come in the store between 33 and 60 minutes using this information? And then you're going to tell me, out of the 200 shoppers, how many shoppers will that be? So give it a try. Then I'll put it on the calculator for you. All right. So when x is 33 and when x is 60, your z-score says 33 minus 45 over 12. Harade, what was your z-score for this guy? Just -1, right? Yeah. -1. Okay. Z-score for this?
1.25.
And then what do I do? To go to your chart, take the areas. So you're going to give me the area for this guy, which is 1587, and the area for this guy. And what are we going to do to those areas?
Subtract the high, so
Good. High minus low. Area always positive. Now I look at this and I say 0.7357. Really doesn't mean a lot to me. 0.73 out of my area of being 1 is a good chunk of my area, isn't it? So even if I look at it that way, I say, yeah, a good chunk of this is happening. So if you think in terms of a percent, it sometimes makes it a little easier. It's a probability that the person I pick at random has a 74% chance that that person will stay in my store between 33 and 60 minutes. Now, if 200 people walk in my store, how many of those, if they follow the same trend as this, will stay in my store between 33 and 60? All I got to do is multiply this guy by 200 because I know my probability. And we measure people in whole numbers. We count 1, 2, 3. We count people discretely. So how many people did you get?
147.
147?
Yeah. But it's just 0.14. It's round to 147.
Okay, 147 people. Okay, are we good with this? Now, your calculator, if you like a calculator, there's a number of ways to do this. So the first thing you can do is just do a z-score on this. Just put this in with a z-score. If I'm going from 33 to 60, so I'm going up to 33 first, I need my area. So I've got a lower limit, I'm going to stop at the 33. I found my z-score to be -1. I'm going to keep it on a standard normal curve. I'm just looking for my area. There's my area, 1.1587, just area. Then I do this again, and I find my other one, just using my z-score. My lower level, I'm going to stop when I hit the 60, which I found my z-score to be 1.25. I'm leaving myself on a standard normal curve because I just want the areas. There's my 0.844. Then I subtract my area. I can do it that way. I can go to my normal CDF. I could put both my z-scores in if I like. I could say, well, I found the lower one to be -1. I found the higher one to be 1.25. Tell me my area in between. And there's my area in between. You can do it with your z-scores. Or, like we did yesterday, we took a look at, I can bypass this whole thing right here. I can bypass all of this by going to my calculator and saying, okay, I'm going to use my x values. My lower limit is 33. My upper limit is 66. But now, because I put x values, I can't use a standard normal curve. I have to use a normal curve, which means I have to tell it the mean is 45, the standard deviation was 12. It's going to come here. It was 60. Okay, I'm sorry. Let me change this. Thank you. So now I come here, and isn't that my total area that I found? 0.757356. Did we find 7357? Round it to 7357. Isn't that what we found? So there's a number of ways you can use your calculator step. If you go this way, when you use your x values, you have to put in your mean, your standard deviation. It will bypass. I don't have to do any of this. I write my probability statement. I put it in my calculator. I say 7357. This is all I'm going to get. I don't need to do anything else. You can do it with just your z-scores and find your z-score areas. You can do it without the calculator, whichever way you like. I usually, like I said, half my kids in the class like the calculator, the other half doesn't like the calculator. All right, so are we feeling these guys? You ready for an assignment, or you want to do one more together? One more together? All right, one more. All right. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the U.S. is 134 milligrams per deciliter. Assume the triglycerides level of population of the United States is normally distributed. We have to know this. With a standard deviation of 35 milligrams per deciliter. Here's our mean. So let's pull out your information. You don't get a lot. You get these two little pieces of information. So make sure you pull them out. You randomly select a person from the U.S., a random person. What is the probability that that person has a triglyceride level less than 80? So let's write your probability statement. I see the word probability. So here comes my triglyceride level. It's less than 80. Triglyceride level is my x value. So how do I say my probability statement? X less than 80. So what I'm looking for is x less than 80. Alright, so now I'm going to build a chart. I want these graphs. I want your sketch. I want your x values on the top. I want your z-scores on the bottom. So we're going to start with 134. We're going to add 35 each time. If I have this one. Yes, I do. So it's 169, 204, 239. And then we're going to go the opposite way. 99, 64, 29. Remember, these should always be increasing. You read left from right. Your x value should be increasing. So if I look at where the 80 is, 80 is over here somewhere. Am I looking for a small number or a large number? Less than 50, more than 50? Less than 50. Probably a lot less than 50, right? So I find my z-score. You have to know this formula. However, because my z-score is negative, I'm in the negative side, right? I have to subtract to get a negative number. The only two things you can possibly subtract are the x and the mean. Those are the only two things that go together. So my x value is 80. My mean is 134. If I subtract 134 minus 80, I get a positive value, right? So if I subtract 80, the x value, minus 134, the mean, I get a negative value, which is what I'm looking for. So use your chart to kind of tell you, should I get a negative, should I get a positive? And your z-score comes out to be negative 1.54. And we figured that, right? It was between the negative 1 and the negative 2 somewhere. All of this should actually gel. It should make sense when you do this together. So I looked up my area, and I get 0.0618. And I said it would be less than 50%, and that is my area to my left, and it's far less than 50%. So let me put this in my calculator. I'm going to put it in my calculator and see if this is right. I'm going to use my x values. I'm on my lower level of my x value. I don't have a lower level. So, negative 999. I'm in my upper level. My upper level is at 80. I want to go from the left and stop at 80. My mean is 134. And my standard deviation is 35. You have to put these in when you use your x values. I paste, and I get 0.0614. Now, the reason why your calculator is a little different than this, because of this. We rounded your z-score to 2 decimals. Your calculator doesn't. It's a very, very exact in your calculator. So when you're doing this, if you're on a test, you'll say to me, calculator. You're going to have to tell me calculator, otherwise you're showing no work. So you're going to have to tell me what your calculator step is, so that I know you used your calculator, because your answer will be slightly different than you're using your formula. You can do this just to find your area for your z-score. You can do this to put your x values in. Whatever you like to do, or not use it at all. I'll always use the formulas when I'm using this up here, and I'll throw the calculator in there. So are we comfortable with this? All right. So as an assignment, and you don't have to take this home, you can work on it in class, and then tomorrow we can finish it up in class. Here's the assignment, if you can kindly write it down. Okay. You can start it now, like for the next 5 or 10 minutes, and then tomorrow we'll finish it in class, and then go over it. Remember, follow that sheet that I gave you on the back of the page there. I want a probability statement. I want a sketch. If you use your calculator, tell me calculator. You'll probably go right from your probability right to your answer. If you do the other, I want your z-score formulas. So kindly write this down because I'm about to take it off. Hurry up.
I think we should do a probability on our chances of going home early.
Yeah, I don't know. This is Newburgh, remember. And everybody asks me, I always say, this is Newburgh. Who knows? everybody was closing and dismissing early. We didn't.
I hope you don't, because there'll be a lot of traffic from you.
Yeah,
I got it out at 10 to 10.
I don't know what his plans are ultimately.